Alright, so we have introduced you into both of the light equations. This is where we left off. Before I get too carried away, I need to remind myself about tomorrow and the wonderful PSAT that I will be administering in my room tomorrow. So there will be no first period or 8th period chemistry tomorrow. I know it breaks your heart. We're so saddened.
Absolutely, it sure does.
And the distress to you that the fact that we won't be in here, you know. No chemistry.
Beat around the bush.
We got it.
Yeah, we got it.
Don't come.
Yeah.
You will be counted out. Hey.
Oh well.
So, these two light equations. Today we're going to do something I enjoy. I want to get you exposed on like how we're going to work these, but I want to try something a little different today with it. You guys ain't got to work any, so today I'll work a couple, but then I want to trade places for a little bit.
Are we getting Mr. John back?
I heard trade places in a major welcome.
Mitch Raleigh, you know what I remember? Stop erasing.
I remember 6.0.
What is the definition of an inverse?
6.0.
Define the correlation in this.
Yeah, you're right. Are you going to be on the bus today?
Huh?
Are you going to be on the bus today?
No.
Are you going to be here tomorrow?
No.
Oh, next week.
I was like, can you send a message?
Why do you write determine like that?
Because in physics, if you take physics next year, you'll see a lot of stuff we do.
Because I just wrote a triangle, so I thought.
It's stuff like this, like I'll
I'll
do.
take it next year.
Yeah, me
Take
too.
it next
You
year.
like I do a lot of deltas. So my delta is. So now it's like the same motion as doing a D, so it's kind of just took over. I can't do that anymore.
But you just did.
Yes, the thing
Believe
about
in
next
Because I have to, I really do. I really have to think about it.
Do you teach physics like you teach chemistry?
Yeah.
As good?
Well, I don't know whether you consider what I'm doing good or not. It's very similar.
Compared to my other teachers, I have.
It's very similar. I'll say it that way.
So saying you're bad, but compared to everyone else.
Determine if a wave of electromagnetic radiation is dangerous if a photon, that wave, has, not is, has
What's that word right below radiation?
photon.
Have we talked about that?
No, we're not talking about it yet. Alright, so I'll give you a second to get this, but this is the question that's being asked. You're being asked to determine whether or not a photon of electromagnetic radiation is dangerous, and what I give you is this number with this unit of 3.57 times 10 to the negative 19 joules. Now, you have seen the electromagnetic spectrum. We have worked with the electromagnetic spectrum a little bit. You should be becoming best friends with the electromagnetic spectrum. See?
Yeah.
Sure.
Fantastic. So, what is the key to determining if the electromagnetic radiation is dangerous?
How much energy?
Further down the line.
Lots of it, farthest left. How much energy?
There's a magical point on the electromagnetic spectrum. Where's it
If
at?
it's past the visible light spectrum, it's past
More energy than the visible.
If it's past the 400 nanometers, so we're right there at the 400 nanometers at the visible light spectrum, right at the end of it. If it goes past that, dangerous. It can lead to it can lead to problems. So, whenever you're setting this up, like always, you're going to find you a starting point. What are we starting with?
3.57 times 10 to the negative 19th power.
Beautiful, but the joules tells you this is what? What?
Energy.
Energy. So I'm starting with energy. Now we're trying to find what piece of information we're trying to find to determine if it's dangerous. In order to do that, you just told me the cutoff point on the electromagnetic spectrum. It relates to what? What of those values? We've looked at nanometers as a measurement of dyno, which dyno is
B.
Frequency?
No, free.
Wavelength.
Wavelength.
I'm trying to figure out what dyno means.
Yeah,
If we would have said lambda.
It's a funny thing. It's lambda, but people
funny
call it
little
dyno. I love it. I think it's hilarious.
I think we're tripping.
Okay, so we're starting with energy, but we got to find ourselves here at wavelength so that we can make this determination. So when you look at a situation like this, it's a dead giveaway if you've not been given frequency, or if you're not being asked for it. You're going to have to use both of them. So if I'm starting you at energy or I'm starting you at wavelength and I ask for the other one, you get all pull for it. This is a really good question because I never tell you anything about wavelength. You have to figure it out. I know, it's like, I look at you and I say, hey, inside your skull is this thing called a brain, and I want you to use it.
What's a brain?
Can you use it if it's dead?
No.
Okay.
Alright, so we're starting here in energy. So develop an idea of how we're going to get there. So energy is equal to Planck's constant times frequency, right?
Yes.
Now, I need wavelength. The other one is the speed of light equals lambda, which is wavelength times frequency. That's why it looks like a dinosaur, I guess. People have started saying that C equals dino, V.
You want to know what keeps me up at night about my brain? Yeah.
Dying in suspense.
Okay, well,
Even though I think I'm going to regret this.
well, it's kind of just like, man, we don't really understand our brains that much. Like, oh, if we just had a bigger brain, we could understand it. But then the brain would be more complex and more big because we were smarter to understand it, so we couldn't understand it still. But if we were like, well, maybe if we dumb it down a little bit, then we'll be able to understand it. But if we dumb down our brains, then we're too dumb to understand the dumb brain.
God.
I regret that.
I have a counter.
Anyway, so we're trying to find wavelength, which is right here, right?
Yep.
So we got to get wavelength by itself. We're multiplying wavelength times frequency, so if I divide both sides by frequency, frequency will cancel on the right side, and I'm left with lambda, wavelength equals speed of light divided by frequency. Now I've got here, you guys mentioned physics today. It's a good thing. I'm going to lay a little bit of foundation for something I like to do in physics to help kids out in figuring out formulas and stuff that we're going to use. Look at what you've been given and determine whether or not you can use this equation. Do you have wavelength? No, you're trying to solve for it. Okay. Do I have the speed of light?
Yes.
Yeah, it's a constant. What about frequency? We have frequency?
No.
No. So I have two x's in here. That's a problem. I can't use it by itself, which tells me I'm going to have to use the other one as well. Now on there, what is useful to me is what I'm trying to find. I'm trying to find frequency. Frequency is in there, so what I can do is rewrite that equation and get frequency by itself so I can solve for it. So we will yet again, we will divide, but we're going to divide by Planck's constant. So that'll leave me with frequency is equal to energy divided by Planck's constant.
Which is 8.
Yes. So now we can start working this problem out. So we can look at the energy we were given, the 3.57 times 10 to the negative 19 joules. Divide that by Planck's constant, which I hope you're starting to memorize it. 6-point stitch times 10 to the negative 34 joule seconds. Joules will cancel, leaves me with inverse seconds, which is hertz, which is what I'm trying to find for frequency. Now we punch this in a calculator.
What's that exponent at the bottom?
Negative 34.
Okay.
It's, okay.
So what's going on with the
5.3876
equals
times
E
10
over
to the 14.
wavelength equals energy over?
So there is this piece. So I get 5.3879 times 10 to the 14 hertz. I want to pause for a brief interruption brought to you by our sponsors, Mr. Hall. Mr. Hall says you should get your calculator up and type this in yourself because many of you messed up on last quiz because you jacked it all up. You need to know how to punch things in a calculator and how to read them.
So we're not using that one, we're using the top one.
Whoa, did I say we're done yet?
No, I'm confused on how we got here so far. Give me a
Well,
rundown.
you can't use that one alone, so you use the other one to supplement, so you can't use that one.
Beautiful rundown.
I was not listening. I think I'm gonna
Drake gave you Drew Brees explanation for the breakdown.
Yeah, see, I was writing all that down, so I wasn't listening.
Do what?
Can you tell me how to type it in right?
Okay.
Y'all got this.
I forgot how to do that. Do we do that little thing?
Yeah, that's
All
how
you
I
have
Can I get a
is
fraction?
you use all for C.
What do you got? No.
Okay. So you have to have both. That's what you're doing up here. Yeah, all you have is speed of light.
And what's those X's and arrows?
He's just saying what you have. You don't have light within you. That's just
Second function D.
you always have the speed of light because it's constant.
It's the second.
And then you always have H. It's
Okay. Now there, what you type in next is going to be the
you have
number.
those two.
So it's
And then you walk away, and then you'll have two.
Yeah. 19.
Oh, so you can get your frequency because you can solve for that because we already have those two values.
Yes.
So once we get that value, we plug it in.
There you go. Good job.
I didn't understand what you have now.
You're divided by, so you divide
I see, yeah.
in parentheses.
This is just
Oh,
a
yeah,
question.
you don't say it.
6. 626.
I kind of figured out how to do it.
Same thing, seconds.
Because I was like, okay, you're
I'm just
plugging
slow.
in, so you're plugging the numbers in. Now, you can look at it.
In parentheses. This is the time if you need help, ask me, ask a friend, ask around.
Which means we put
I
in.
like it.
Mucho grande.
My family's Spanish. I don't know.
Me either. Just sounded cool.
What'd you say?
What?
What'd you say?
You said
Let's see, you do problem? Yes, no, you get it done. What you doing?
I mean, what?
On delay.
I'm trying to figure out what you said in Spanish.
Don't worry about that. Figure out like what you want to write down Planck's constant down there. So you got these notes, so when you're studying for your quizzes next Tuesday, you get an A.
But what if I don't say?
Then you no get A.
Well, I think I know.
Unless you're a freak of nature, then those people sometimes can. Okay.
Right.
Oh, I have no idea. I haven't solved the problem. I came up with this out of my head.
Okay.
And why does it hurt? Because it's wet. Okay, I got you.
I just did it twice. I didn't
Because it's chemistry.
I didn't round.
All right, so now this whole thing's changed because I now have frequency.
Yes.
So now I can solve for wavelength, which will set this up as 2.98 times 10 to 8.
Wait, so we're using, what are we using now?
You gotta use the second one.
Oh, I have check marks and X's.
Makes sense now.
That's telling me I don't have that, I have that, I have that.
Why do you not have the donut?
Because we're trying to find it.
I got a question.
Yes.
Are you gonna
Oh, I
make a
can't
video
read it. Okay.
of like a practice?
Wait a second.
Yes.
Like stuff like this, like you did the other?
See, I will.
Okay.
Okay. I got one question. Can you walk me through how you got that one
I
that
guarantee.
The one what?
He's shaded.
the dyno equals speed of light divided by the
I got that because when you look at it, speed of light equals wavelength times frequency, right?
Yes.
Okay, I'm trying to solve for wavelength.
Yes.
So I do the opposite of what's being done. I divide by frequency. Whenever I do that, the frequencies cancel, and it leaves me with wavelength by itself.
Okay. I see it now.
Okay.
It was just flipped around backwards. I'm like, what is that?
You what now?
It's the same thing.
That's the speed of light.
Let's just know that too.
Yeah! Alright, speed of light. Now we divide it by the number we just solved for.
Let's go.
5.3879 times 10 to the 14th hertz. I gotta give it to Owen Keeney. I like what he said. Let's take a second and let's get rid of hertz.
I
It's funny because it's inverse hertz. And take a second. You like it, didn't you? Why?
Yeah, like.
On the bottom there, joules times seconds you had on the other one. Where'd the S? What? Did canceling joules get rid of it, or is it just?
No, this is inverse seconds. It's the same as 1 over seconds, which is the same as inverse seconds, which is the same as hertz.
Gotcha. I did not know that. I know it now. Thank you.
Yeah, you missed a day last week, didn't you?
Yeah.
This keeps happening. You keep seeing the pattern, like you miss, you come in, you're like, where'd that come from?
Well, I got it now.
Yeah.
Then he knows it, so it works out.
Okay, so we punched that in the calculator now. I saw you. I saw instant questions. So, yeah.
So once we get this, we have lambda, which means we can solve.
Oh, yes.
Oh. Yes.
And I got, let's see what you get. I get 5.5309 times 10 to the negative 7. And this is meters.
My notes look so good, Mr. Hall.
Because the hertz and seconds cancel.
Because it's meter over second, which is the same as meter times 1 over second, and 1 over second is the same as hertz.
2 meters over a second.
Well, no. Meters over second
I just wrote the wrong thing.
divided by hertz is equal to meters. Maybe. I hope so. Not meaning nuclear. It's like how.
I'm so used to doing everything on here.
I got 34. I got 25. I got everything.
Alright,
When are you posting it?
Oh, I said my notes look good.
Oh, that's probably good.
Like not.
Which video you talking about?
All of them.
I'll post some today, some tomorrow, maybe some maybe later this week. And I'll be posting video. Okay, everybody good here? Now, question to you. Is this dangerous?
I think so.
Yeah.
Yes, it is.
Yes?
Ultraviolet.
It's an ultraviolet light.
Man, it just smacked you in the face. So everybody's going with the idea that yes, it's dangerous.
It shows it on here that it's been.
yeah.
Really?
It does.
You sure?
Can I tell the next
Wait, no.
Hey, can I help you with something here? You all are falling for a trick. Mr. Hall told you where to cut off it. Wait, let me get the camera so when you're watching this, you understand. Hello. I almost died. We'll put that there. Okay, anyway, so here we go. Mr. Hall looked at you and told you, you all are falling for a trick. You all are wanting to look here. And you're all looking right up here at that, and then to the -7. You're like, oh, yeah, man, look at that. That's ultraviolet. Where did Mr. Hall tell you the cutoff is?
Mr. Hall,
Yes,
I didn't see Ariel Lusk.
she's on her way.
Thank you.
You're welcome. Where did Mr. Hall tell you that the cutoff is?
And makes it to the visible light spectrum.
The visible light spectrum, right here, right? So we're there. That's where it gets dangerous to the left, right? Danger zone. Sorry, take a top run. Okay. So that's where dangerous is at, to the left of it. What is the unit for that? I'm looking really close with the camera. It's nanometers. We're in meters. What do we need to change that to? Nanometers. So let's do a conversion so that I can prove to all of you that you all are wrong.
I was going to ask about the meters, and then you asked if we were right or wrong, so I didn't want to be silent. So I just said yes.
Alright, we're trying to get this thing in nanometers, right? Here we go, let's do it. So 5.5309 times 10 to the something another. Now the key is, look at the difference.
Hold on.
What am I holding on to?
I just
From on the tongue.
I can't think as fast.
Okay, alright, alright.
Alright, now, give me a second. Stand by.
I guarantee that's not my.
Oxygen.
Okay.
Hey, Mr. Hall, FWIW.
What?
FWIW.
FWIW.
Ogle, ogle, ogle.
Foggle Woogle and Vogle. It doesn't mean anything.
Okay.
FWIW.
Alright, here we go.
FWIW.
Ladies and gents, we're starting here at meters, which means it's the base unit, therefore, exponent 0 minus. What's the exponential value for nano? -9. So 0 minus a -9?
9.
9, because it's positive. Subtracting a negative, same as adding a positive. See?
Multiply. Would you multiply the -5?
You would end up adding that -7.
You will add the -7. Thank
That,
you for
I thought
asking.
that was a -5.
It's okay. You will add it. This is where the multiplying and adding thing comes in. You multiply by what's on the unit. There's no exponent here, so you don't need to multiply by anything.
Oh.
Now we add what you originally start with. So a -7.
Yes, yes.
That's
So
where I
two.
get confused.
So this goes 2. Now, everybody mark it down.
2 marshmallows.
Today is a sad day in chemistry. It's heartbreaking. Don't you dare go tell her that I submitted and I gave in to her ways. I'm giving in to Miss Cole's scoot method.
Let's go. That was loud. I didn't mean to.
Here's the thing. You can do Mr. Hall method if you want to look at it. 10 squared is 100. 100 times that will be 553.09.
Yes.
Or you can do Miss Cole's scoot method. I better shut the door so here. Scoop, scoop.
She gonna write this one down on the book.
Scoot method sucks. It's awful. It's horrible. Okay, anyway, if you want to use the scoot method, use it. So, Miss Cole's scoot method, if you don't know what I'm talking about,
Hey, Mr. Hall.
this is what we're going to do.
SCOOT.
You're in timeout. No shot. You see that 2 there? You see where it's a positive? Positive tells you move it to the right. Negative will tell you move it to the left. Grab it. And we're going to move it 2 places. And because it's positive, we go to the right.
2 places.
1, 2. I hate this. I'm dying on the inside. I want you all to know this right now that I want to puke my guts out.
Hang on, can you explain that while you move it?
Someone call me then.
Because you're multiplying by 100.
Puking this class every day.
Okay, that makes sense. But you only do that when it's like that, right?
I
I
got that.
didn't know.
When it's the 10 to the second?
Yes, see, that is correct.
So that's like.
Not the answer yet. Remember, I'm doing this to prove something to you all. How wrong you were when you told me this was dangerous. Because I get 553.09 nanometers. And every last one of you in this room agreed to something that was dangerous.
Except for
Now,
I disagree.
oh, what,
one of
Kendra?
them.
I disagree.
You disagree?
I never gave an answer.
Kendra, I'm so proud.
Let's go, Kendra.
That's awesome.
I never wrong.
Now,
I just want to go against the entire class.
553.09. Can we agree that's about 550? Can we agree that's practically halfway between 500 and 600? Look at your visible light spectrum, ladies and gentlemen. Right here's 500. I give you 500. Right there's 600. Let's go about halfway in between those. Woo!
It's green.
That's green light. If that was dangerous, we'd all be dead.
I wish it was dangerous.
I would really be dead because I went to Marshall and we was green. Go herd. So, question to you: is this dangerous?
No.
No. Explain to me why not.
Because it's our color.
Because
Green.
it green.
Hit green.
Get green.
Are you Mr. Wong?
Get green.
Wang? Wong? Wong. It was Wong, but still
I can
Wang.
handle poison dart frogs.
Oh my
Yes.
god.
Now, questions from you. Give me the questions.
I got one.
No.
What happened?
Well,
Everywhere.
well, you see, we started out of my head. We came up with this problem. We developed a plan. We executed the plan.
Green.
What's confusing me is with
Mr. Rob.
the two
Wait,
light formulas.
here, here.
Yeah, like what is going on?
Okay, so this is all developing a plan. Like, in math, you just jump in, you start doing math. In science, it changes. Develop a plan. So what I'm laying is, I know that you're a senior and you can't take physics, but it's something that I lay foundations for physics. Because the biggest thing is taking your math skills and understanding what's happening and executing it. So we developed a plan that I'm at energy and I gotta get the wavelength. So I start with the energy
Go
equation.
the other way.
And I find out if I'm going to find wavelength, I'll look at this one. Because it involves wavelength, right?
Yeah.
There's wavelength. I need wavelength by
So
itself.
pretty much whatever you're doing, whatever you're looking for, if one ain't got you do the other one.
Anything times.
Yes, you move it around and what links the two together. I stressed that yesterday. What links the two?
It would go that way.
Frequency.
So frequency. So what you'll do, you'll use one to find frequency and then plug it into
That's
the
why I
other.
was like, no.
Yes.
What is it? But my brain was like, no.
Any other questions? That was a great question. Why?
Can you do me a favor and not
Get it.
underline?
Get it.
What? Can you do me a favor and not underline?
Because it's big.
I understand now.
No, it doesn't. Which is really stupid.
Because I want to underline it on my notes and I'll leave it exactly how he has it.
He's putting it in a box.
The box is fine, thank you.
Wiggity wiggity whack.
So is that like all necessary
Because it's
for
measured.
every problem?
No.
Okay.
There's like a
What do you want?
Are we gonna have that question?
Yes, I will let you know the electromagnetic spectrum, because I cannot print off in color, will be left on the view board on your quiz. Listen, I'm laid back and easy going. If you need to get up and go over and look at it, for the love of God, get up and go look at it. Especially you all that's over here. If you all need to get up and go over and look at it, man, go look at it. I'm not going to be like, oh, you're cheating. Lord, no. Get up and go look at it. Any more questions? How you feel?
Like at least $2.
You feel good?
See what messed me up there?
$7 is what
Is
I
that it?
Hey, hey,
Oh.
I have something.
Thermite. It better be thermite. Give
No.
me
What
thermite.
isn't dangerous? How come we can't touch poison dart frogs?
That was a mistake.
We gotta go
If
find
color
it.
isn't dangerous, then how come I can't touch
Now we're really
poison
gonna
dart
break
frogs?
on that door.
That
was
color.
I had this.
Oh, practice cheats.
I hate you.
See what tripped me out?
Oh, you know what? Let's just do this.
It's green.
You'll take some, pass it around.
Huh?
No. Just like grab it.
Poison dart
Keep
frog.
handing it
This
through.
big.
Oh, I wanted to.
There you go. Let's do this. You take one, pass it around.
Let's go.
I hope you tried it.
Alright. What I am giving you
Hey, I need one of those.
is some of these practice problems. Way to go, John. Yeah.
I ain't giving.
And you start with yourself and forget about yourself.
I'm giving.
Yeah, sign out, take a hall pass. So, what I'm giving you is something we're going to do. is I'm going to start and I'm going to work a problem. Then we may not get to it today, but on Thursday, because you know PSAT tomorrow, you'll know be in here. Yeah, Steve? No.
Yes, yes.
So,
For sure.
what will happen is I'm going to flip, because you know how much Mr. Ha loves you? Mr. Ha loves you so much. Yes. Some of y'all have not caught on to the idea of dropping your pride at the door and you're sitting here struggling and saying nothing at all. So we're going to flip this week. I'm going to stand in the back and I'm going to hear you tell somebody how to work the problem.
Can Mr. Ellis come back?
Mr. Ellis can come back, but Mr. Ellis will get fired really quick too.
I don't want Mr. Ellis to come back. Mr. Ellis gives me anxiety.
So, I want to do this to show something to you, and it works so well. I had kids come to me in first period today that told me, I'm struggling, I got no idea what's going on. And I'm like, thank God you said something to me. I can tell it. You need to be real. Some of you have started to come see me during lunch. This is a good thing, you know. I think I'm funny, I'm great to be around. I mean, it helps you with chemistry. That's the whole thing that we're looking to do. You come in here, I'll answer your questions and help you. That's the whole thing that we're trying to accomplish. So what I'm going to do, I'm going to solve number 1. Then we will move forward. So, are you ready? Great. So number 1. Everybody got the sheet?
Sure.
Did I print off an extra one? Is there an extra one later on? Oh yes, please give that to me. That was meant for me. Thank you.
Forget about yourself, same way John did.
No, I had it here on the computer.
Still.
So, how much energy is in a photon of light that has a wavelength of 4.62 nanometers? So, we're starting off with wavelength. There's a wavelength. Ladies, please get off the phones. 4.62 nanometers. Beautiful. Beautiful place to start. What are you starting with?
The C equals dyno V.
Wavelength, and we're going to look at that equation first. How do you know that's the equation we're going to look at
Because
first?
it says how much energy, so you don't know energy.
Okay, so how much energy? So when you look at energy, that's Planck's constant times frequency. Do you have frequency?
No.
No. Can you get it?
Yes.
Yes, by using the speed of light equals wavelength times frequency. Why? We know the speed of light, we know the wavelength, now we just got to do algebra and find frequency. So, I'm multiplying, let's divide both sides by the wavelength. Why am I dividing by the wavelength?
Because that's what you know.
That's what I know, and I got to get frequency by itself. So frequency is equal to the speed of light divided by wavelength, right? Somebody just please say yes.
Yes.
Thank you. Thank you. I was like, put me up to my knees. Okay, so let's see. This is equal to...
Tim Blankenship, Garrett Blankenship, Kara Harvey, and Jacob Haynes to the office.
This is equal to the speed of light, which is 2.98 times 10 to the 8 meters per second. Divide that by the wavelength. Does anybody see a problem? I'll give you a hint. Mr. Hall stopped and asked you, there's a problem. Somebody pointed it out for me.
It's not going to be converted.
It's this many of them.
You all are hopping around and saying the same thing, but in different ways. Yes, we need to do a metric conversion because the speed of light is in meters per second and our wavelength is in nanometers. So what's it got to be in? Meters!
Never mind.
It's easier to convert that to meters. So, let's start with 4.62 times 10 to something another. Nano. What's the exponential value for nano? -9. Minus base unit 0. So that's equal to -9. So 4.62 times 10 to the -9. So that's the new number. So 4.62 times 10 to the -9. That's meters. Now that's a good thing. We have a good thing now. Because meters will cancel. What will this leave me with? What will it leave me with?
Hertz.
Hertz. Oh,
What hurts?
this problem hurts so good.
Explain how that.
Right now, it is Hertz.
All right, this is how. So I'm going to use a different color to show you the unit breakdown. So here's the thing. This is meters per second. That is divided by meters. It's the same as meters per second times 1 over meters, right?
Yep.
So the meters cancel. You multiply across, it gives you 1 over seconds, which is inverse seconds, which is equal to hertz. Okay, back to the problem. Now we punch in the calculator. I hear some of you going at it. Very good. Punch stuff in calculator. Make sure you know how. Prepare you for quiz next Tuesday. Oh, y'all, I get the number. Hopefully we get same number. So I get 6.4502 times 10 to the 16th
Yes.
hertz. Woo, man, this thing hurts.
Even
All
though I
right.
might have just put the wrong meter on it.
Do what?
But even though I just put the wrong meter.
In other classes like Skirt and chemistry.
I forgot we got rid of meter.
You caught your mistake. It's a good thing. I'm going to erase right here just so that I can put this in a different color so we can distinguish the difference. So energy is Planck's constant times frequency. Now I have frequency, which means I can now move up here. Right? So let's move up here. We're trying to find the energy. So energy equals Planck's constant times frequency. What's Planck's constant? Give it to me. Let it sound like a music.
6.6 times 10 to the negative 34.
Everybody was off time, but that's okay. You got the number right. What's the units? Nope, that's speed light.
Joules.
Joule seconds. Very nice. So 6.626 times 10 to the negative 34 Joule seconds. What are we going to multiply that with?
The number we just got.
6.4502.
502. 10 to the 16th power. Hertz.
The 6.4502 times 10 to the 16th hertz. Or, a much simpler way of saying that number we just solved for. Beautiful job. Saved a lot of oxygen. Mr. Hop could use some right now.
It's like writing mold with an E on it.
Oh, man. Oh, whatever. The such thing. So, 6.626.
Are we gonna have to do another metric problem?
What?
This is ridiculous.
In this class? Absolutely. Me.
I mean, in this problem. Because of the hertz and the joules.
Let me go back to it. Hold on. No.
Okay.
No.
Ooh.
2,739 times 10 to the negative 17.
How are you doing that?
And this is joules. I've had practice. I've been at it a little while. Seconds and hertz cancel. Remember, I always take a second.
Hang on, what'd you say, Nancy?
Seconds and hertz.
Seconds and hertz.
Okay.
What'd you get?
4.4029.
Oh. One more time.
4.4029.
Okay, we have a problem. Hold on, let me come to the board. Everybody else, punch that in. Make sure you get it. You do a beautiful job.
Yes.
Let me see what we get. Let's see what happens. Thank you. That's a problem. You had an extra number there. You had a 6. After that's one there. Right here. 6.64.
Oh, okay.
Anybody else have questions? so silent. You are getting it. You knock it out the park. Yes? You will kill the SAT. Why? Because you took chemistry. These poor sophomores.
Chemistry on these?
No, it's not, but it's okay. It prepares you to destroy it. You look at the SAT and you say before you start, you say, I took chemistry with hard destroy you.
It has nothing to do with it.
Yeah, everybody will look at you like you're crazy.
It'll float around on the ACT.
Okay.
Is that all we do?
On that one, yeah. I don't know that I'm done. I got the
Bring the
answer.
notes to the office.
You got Jules?
Yeah, because I'm trying to find the amount of energy for that, right?
Yes.
Now, hear me out, because I know a lot of y'all ain't coming tomorrow because of the SAT.
Nope.
So, Thursday, when we come in here, we're going to switch. And I want to get inside your head. I need to hear how you're thinking, what you're doing. It is crucially important. If you have questions, come see me.